We're looking at the 10.2 to 10.5 review worksheet number 1. A particle moves in the xy plane in such a way that the velocity vector, which is given here, if the position at t equals 0 is at 5, 0, find the position of the particle at t equals 2. So just to kind of keep in mind, the formula that we're going to kind of keep using is this formula where if I'm whatever final position I'm looking for, I can get to that final position by identifying the initial or the given position plus the vertical or the horizontal displacement. So in this case, if I want to find x of 2, the position at t equals 2, I need to find x of 2 and I need to find y of 2. All right, so we can split this up into horizontal and vertical components. So the horizontal component is going to find x of 2 would be the initial position in the x direction plus the horizontal displacement to get from 0 to 2 to find the displacement so we can find the final position, the x value final position. So x of 0 we know is 5, right? And then the displacement or the integral, definite integral of the x component of the velocity from 0 to 2, we can just work through power rule here and then plug in our upper and lower bounds, and that will give us 4, and then so 5 plus 4 is equal to 9. So this is going to be the x coordinate of our final position. The y coordinate, y of 2, we're looking for y of 2, and then we have to go back to what's given to us. We are given initial position. So initial position, the y value is at 0, so y of 0 plus the definite integral from 0 to 2 of the vertical displacement, okay, integral of t cubed from 0 to 2. So work this through, that will also give us 4, so then 0 plus 4 is equal to 4. So that our ordered pair will be at 0.94 when t is equal to 2. Number 2, the position of the particle at any time t is greater than or equal to 0 is given by x of t and y of t. Find the magnitude of the velocity vector. So the magnitude of the velocity vector, think of it as the distance formula. The way we find the absolute value of the velocity vector is we take the square root, this is just a rule here, of x prime squared plus y prime squared. So let's find x prime and y prime. X prime, going through power rule, is simply 2t. Y prime, the derivative going through power rule, would just be 2t squared. And then when we plug into our formula, it's the square root of x prime squared plus y prime squared. So x prime is 2t, so quantity 2t squared plus quantity 2t squared, 2t squared quantity squared. And so this now represents our magnitude velocity function. And then if we plug in 5 into each of the t values, then we can find the magnitude of velocity, which is going to reduce to be 10 root 26. Okay, so if we want to find the total distance, you can think of it as arc length, and arc length is just the accumulation of the magnitude of the velocity function. So here's our velocity formula. We take the integral from a to b. So our a value is 0, our b value is 5. So from 0 to 5, the integral of 2t quantity squared plus 2t squared quantity squared. And we can work this through from 0 to 5, root 4t squared plus 4t to the 4th. We can factor out a 4t squared from both terms. And then we can take the square root. The square root of 4t squared will just be 2t, so we can pull the 2t out from under the square root, but the 1 plus t squared stays inside. So from 0 to 5, we can work this out by hand by going through u substitution. We let the u value be what's inside the radical, 1 plus t squared. Find the derivative of u with respect to t, which gives us 0 plus 2t. Solve for dt, so dt is equal to du over 2t. We make our substitutions, convert everything to be in terms of u and du. So 2t stays initially, and then the square root of 1 plus t squared becomes square root of u, and then this becomes du over 2. d over 2t cancels out with the 2t, so we're left with the definite integral from 0 to 5, u to the 1/2. So u to the 1/2 going through power rule becomes u to the 3/2 times 2/3. Convert our u value back in terms of t. and then plug in our upper and lower bounds. So the 5 goes in first, and we get 26 to the 3 halves. Then we plug in a 0. 0 plus 1 is 1. Okay. Part C, find dy dx as a function of x. So the first thing we need to do is we need to eliminate the parameter. So we're going to just go ahead and decide to solve for the t here. Be a little bit easier to solve for the t here. So if we solve for t, we can move the 3 halves over, 2/3 over, and then take the cube root. Okay, so then once we solve for t, we can plug into this formula, and then we can find dy over dx. All right, so y is 2/3 to t cubed. If we solve for t, we can move divide both sides by 2/3, which is the same thing, multiplying by 3 halves. Take the cube root, and then make our substitutions, because x is t squared minus 3, so t can be replaced with 3 halves, y to the 1/3 squared. And if we distribute that exponent 2 through, we get 3 halves to the 2/3 times y to the 2/3 minus 3. And then we can begin to solve for y here. X plus 3 is equal to 3 halves to 2/3, y to the 2/3. We can divide both sides by 2/3, 3 halves to the 2/3, which is 2/3 to the 2/3. And then if we solve for y, we can raise everything to the 3 halves. Okay. So once we raised everything to the 3 halves, we now have an equation. Okay. Y in terms of x. So now if we find the derivative of y with respect to x, then we can have our write our expression here. So dy over dx, we're just finding the derivative of y with respect to x. So 2/3 x plus 3 to the 3 halves. We can go through power rule, chain rule, sorry, bring down the 3 halves, keep the parentheses, subtract 1 from the exponent, multiply by the inside function's derivative, which is nothing more than 1. And then we could attach dx over dx, but that just washes out. So here we have dy over dx.